Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Container Journal webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great panel discussion today, which I'm really excited about. It's about container management, configuration monitoring, and more. But before we get started with that, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, or if you just want to watch it again afterwards, that's fine. You'll be able to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And we are taking questions of the audience, so if at any time during today's presentation you have a question, please don't wait, don't hesitate, just use your GoToWebinar control panel, submit your questions, and we'll try to get to as many as we can after our discussion. Okay, we will kick off today's webinar now, which is, as I said before, container management, configuration monitoring, and more. Our guest panelist on today's presentation webinar is Gianluca Arvizano, who is a site reliability engineer at Influx Data, and Cherie Ivsan, who is product manager at WhiteSource. Welcome to you both. Thank you so much for joining me today. Appreciate it.
Thank you. Thanks for having us.
Thank you. So I'd like to actually start out by asking Gianluca to just tell us a little bit about yourself and what you do over at Influx Data.
Yeah, at Influx Data, I work as a site reliability engineer. So I try to take care about the cloud service that we provide. So the one that is running now, and also the version 2 that we released a few months ago. So I take care about the production, and I try to work with other teams to improve the reliability of our services across the board. So issues about scalability and inflexibility usually are handled by a group of SRE people that helps and collaborate with other teams to solve the issues or try to figure out what's going on.
Excellent. All right, great. And Cherie, I know you are no stranger to our webinars, but please tell us a little bit about yourself and what you do over at WhiteSource.
Sure. So my name is Cherie. I'm a product manager at WhiteSource. And basically our job or our challenge in WhiteSource is open source management. So we help our customers manage open source, whether if it's regarding licensing, security, or actually knowing what open source components the customers use. So this is our main job and our main challenges. And of course, with that, we have many additional challenges, such as containers, for example, which we're going to discuss today.
Excellent. All right, great. Well, welcome again to you both. Really appreciate your being here. So today's webinar is going to be loosely based on an ebook that we have put together that's going to be living on the containerjournal.com site. It's container monitoring. And everybody who registered for today's webinar is also going to receive a download to access they're going to use a link to download the ebook for their own use. So you can look out for that in your email following today's webinar. So, okay, so let's get right into it. So obviously we've kind of broken today's webinar up into container management, configuration, and then monitoring, and then the more. So I thought we could kind of start with the basics here. And Gianluca, maybe we can talk a little bit about the challenge that containers are, when we're talking about configuration in container environments, what are some of those challenges that exist right now?
Sure. Yeah, I think there are a couple of challenges. Like some of them are common compared with more traditional environment. So we have the same issue when we work with VMs or when we work with other solutions that are not container. But with containers, we also saw a spike on how dynamic an environment is. So even before like container, a lot of people was using VMs on cloud, and we already had a feeling about what a dynamic environment is. But with containers, we just went far away from that. So containers goes up and down, and they need to have their configuration, and the configuration has password that doesn't need to be leaked. So there is also a security concern in that. And we all know in the industry that configuration change and update are one of the vector for like trouble. We know that you can be the best developer ever, but when you need to apply a configuration that needs to go over a lot of containers, that's the pain. And there is something we can do, and something that is just practice that we need to do in place. So I think it's hard because it's not just a technology issue. It requires also a cultural push from the company and from people in the team. And so it's a very it's a collaboration issue. Is where do we place the configuration? How do we get them into the container? So there are a lot of aspects that comes from a sharing environment that is even harder to manage than just the problem itself.
So so from what I've gathered so far, it's that ephemeral nature of containers is kind of a blessing and a curse. That you've got the ability to kind of rip and replace as needed, kind of on the fly. But when we're talking about managing multiple clusters, I imagine that becomes even more challenging. So I mean, does it become more of a challenge as the number of container clusters increase?
That's definitely true, and I think it's also, other than being harder to roll a new configuration, it's also like the risk improves because you have maybe a globally distributed kind of the set of services, and you need to figure out, okay, I need to find a way to make this configuration update rolling. So you can't really ask or required for a configuration change to happen all over your cluster at time 0. You need to have a rollout in place. You need, and it means that you also need to figure out how to make the old configuration to work when you are at the same time that you are rolling out a new version. So as bigger is your environment, and harder this situation will become. And yeah, I think other than for the fact to be ephemeral, it's also all the configuration management. It's hard because you don't really have you can really push that into the images. I think we have a very different set of issues. Like few years ago, I think the issue was, how do we technically push the configuration into the application? How do we place the configuration inside a container, or how our application reads the configuration? Does it do it via environment variable? Does it do it via configuration file? If it does it in a configuration file, how I'm gonna download it, or how I'm gonna find it into the container? So we had a lot of people that had security concerns because issues because they was pushing that configuration inside the container image, and this is a bad practice that you shouldn't do. So back in the day, it was way more like a technical issue. Today, as I said, it's more like a cultural and organizational issue that you need to solve in a different way. So now we have we can develop application that knows where to find the configuration. So the configuration, place a configuration inside where the application is not even a concern from an operational team. It can be a concern for the development team that needs to pull the configuration from outside, from a centralized place. Even it can be like console, or it can be a key value store in your cloud provider. So I think now from a technological perspective, we are in a good shape. With config map and Kubernetes, it's easy to fill a place where an application is running. Before, everything was environment variable based, and it was very hard to do. Now I think technically we are in a very good position. Now it's in the development team, they need to figure out how to make it safe and secure. But yeah, managing the update is definitely something a lot of work that we didn't figure out yet. I mean, huge companies or some teams figured it out, but it's not strong and friendly, available for everybody, as other stuff are right now.
Okay. So is that a question of standardization then, or is it other factors that are kind of making it a little less friendly, if you will?
Yeah, I think it's mainly related to like sharing. Like we lack on experience on how success story around that works. So there is definitely you know, we just need to learn more from each other as we did in the past for container itself or for VMs or cloud provider. It's just that we need to share more and you know, get from other companies how they are successfully managing their configuration.
That makes sense. So, Cherie, when we're talking about configuration, then where does security fit into this conversation? Is it, you know, does security play as large a role during the configuration as it does during the monitoring part, or you know, is it even worth having the conversation about security during the configuration phase?
So yes, definitely. I mean, today we speak about continuous security, right? So we speak about the fact that from the first, like earlier stages of development, all the way through, you know, the design and the research, and of course the deployment and the monitoring later, the security has to be there. And again, as we discussed, like the nature of containers is ephemeral. It's tricky to configure, it's tricky to monitor compared to traditional applications that were running on virtual machines or even bare metal. So definitely, if you have like a centralized management for decentralized systems like containers, security is a very big issue. I mean, it's both about things like, you know, secrets and role-based access and being able to configure specific things that are like security best practices that you have to always keep. So this is like the, you know, like the needs to be the organizational policy when we're speaking about configuration, to basically have these best practices that you just have to take and sort of copy and paste in terms of security. So this is my take for, you know, regarding the configuration part.
All right, great. So, you know, one of the things that's kind of come up in conversations is the topic of configuration drift. And I'm wondering, is that maybe, Gianluca, this is something you can discuss a little bit more. This whole topic of configuration drift, what is that exactly? And, you know, what does that have to do with you know, within the process of managing and configuration, container configuration. Sorry, that was hard for me to get out. So.
Yeah, I mean, you know, it becomes a concern because it scares everyone to change the configuration from 1 to like 100, like in time zero. You always need to have something like a rollout policy, and these rollouts based on your internal environment or how you prefer to do it can take hours. Technically can take hours or even days. Sometimes it is because you need to test the configuration, so you are happy to take like 10 days. Other time it is because you are running different version of your application, so you need to have different configuration because that's what you expect. Sometimes it's just a technical issue. Your environment is so big that you can't really do it like in a reasonably short amount of time. So as I said before, you always need to have your configuration working in a way that will not break whole running configuration of your application, even if you are the one that like manage the rollout, because you never know if you will need to come to roll back or if you need to do a new deploy with your configuration. So I think I really like to explore more the idea that, as I tried to say before, that your application pulls the configuration from a centralized environment, so you don't really know to place the configuration inside the application, but it's the application that knows where to go and take that. So the idea, like, you can start in a very basic way, like in a S3 bucket, or you can go and, Amazon has the services to do encryption and decryption, and you have the MEI, so you can kind of figure out a good flow for that. Or you can use Vault, that is a secret manager, where you place all the configuration, and your application will just need to know its key and its identity, and it will get whatever it needs. I think this is a very good practice because, as I said before, it's a communication issue, because usually the developer are doing the application, and they write the configuration and they pass the configuration to somebody else that will do the work, and it will do the update. And this jump between people and teams usually can drive to an issue. So if we can reduce that needs, it would be, I think it would be a good a way to change the how it's working, and I think it would get better. So it's like a responsibility issue. Obviously, there are people that knows how to look at the production environment, and they have the tools to figure out what's going on. But as a developer, we need to know that a configuration is crucial for our application, and also how you pass that information is good. So if the application will be responsible to do that step for pulling what needs to be done, I think it will reduce the risk for issues. So.
Okay. All right, great. So Cherie, are there any security concerns when we're talking about the configuration drift? I mean, does that introduce a level of lack of security that maybe might not be there?
I think configuration drift is more related to the actual, uptime of your servers. Most of the issues, or the downtime in applications actually happen because of bad configuration. I mean, there are many ad hoc changes and updates, and then after some time you actually get to a situation where you have a configuration drift and something goes wrong. One of the tools to actually avoid that is using automated configuration tools that we discussed, like Puppet, Chef, stuff like that. And also in terms of something that is related to security is, of course, that Kubernetes relies on config maps and Kubernetes secrets, right, to ensure the containers and the correct configuration. And that's also where you can set up the rotation of things like database IDs or passwords, and actually everything can be scripted and scheduled and automated. So actually without configuration management, it would have been very hard to manage that, because manually to rotate all your secrets and make sure that your applications are aware of that is something that is very challenging to do. And the automation of configuration and configuration management actually helps us to do it in a very easy way and straightforward way.
All right, great. Excuse me. So we've gotten a couple questions in so far, and I think now actually might be a good time to address some of them. So if you guys don't mind, we'll go into a lightning round here. Cherie, the first question, can you talk about security in the container image creation stage?
Yes, of course. So when we actually create the container image, it's usually in the build stage. So if we think about it and we try to sort of build the timeline of the software lifecycle, so the first step would be the coding or even the research, where I actually choose the component that I need to use and then I write the code. And then the next part would be building the application. This is usually where we will have automated tests, functional tests, and maybe also security tests. And this is also where we pack our application into a container image or a Docker image. Now, in terms of dealing with the general aspect of container security, usually the automated tests that we do as functional tests, we can add to those also some security tests, right? So as part of the build stage, you already have some tests that are running as part of your application. And if something goes wrong, the build will fail. So what we would usually recommend is, as part of the build stage, you can also add some security testing things. So things like scanning your open source and dependency scanning, making sure that you have the static analysis tests in place, having an open source tool even to check if you have any issues with secrets or anything in terms of passwords or tokens that are hard coded. So this would be a very good stage to do it right before creating the image. The next step right after that would be checking for the image inside the image registry. So we can, again, do things like dependency and open source scanning in the registry itself. So right after the container image is created. I hope that answers the question.
Okay, all right. Well, I'm sure if it didn't, then we'll get a follow-up. But thanks very much for that. So there's another question here that maybe Jean-Luc, you can kind of tackle for me. Do you use source control on configuration files? And if it's a question better for Cherie, then whoever is best suited to answer that question. I'll throw it out to you.
Yeah, I mean, we do a little bit of both. So for what concerns the infrastructure, a lot of the configuration comes from a source control. So we have a kind of a Git-based workflow. So we do a pull request on our repositories, and there is a pipeline that starts and validates that the configuration has sense. There are code review on that from other member of the team, and when we merge, that starts to roll out. For other configuration that are that maybe has secrets or they are tied to the configuration to the application, as I said before, we usually try to reach like an external configuration manager like Vault. So we do both. Really depends on, like, for the infrastructure, it is a little bit less dynamic. We tend to use the GitOps based, and for other stuff we use the source control, the Vault.
Okay, doesn't sound like there's a hard and fast rule there, though.
Yeah.
Okay. All right, great. Well, let's go ahead and move on to our next topic, which is monitoring. Obviously, that comes after configuration. So let's maybe we can start a little bit by talking about some of the the considerations that you need to keep in mind with container monitoring. And Gianluca, why don't you start, and then Cherie, maybe you can kind of jump in with some of those security considerations when it comes to monitoring.
Yeah, I mean, to be honest, those two topics are more related than what we can think about, because one of the way we have to catch misconfiguration is via monitoring. So there is no other ways. If you make a wrong API, put a wrong API token, your API request will start to fail, and your SLO will trigger an alert that you will get paged. So a lot of the stuff that the configuration usually requires an application to restart, so new containers, and your monitor starts to listen and watch new application running. So those two topics are related, and if you have a strong monitoring system, you can take more risks on configuration. So you can do more configuration rollouts, you can have a drift that is longer, so it can take longer to go, and you can test them in isolated chunk of your application or of your infrastructure and environment. So there are a lot of different tools that you can use to do monitoring, and it really depends on how effort you are happy to put on the monitoring system. So if you can't really afford to have and manage your own monitoring system, you will go for a solution that maybe it is managed by your cloud provider, or it has a vendor that can manage that. If you can manage that by your own, or for security purpose you need to have that in your infrastructure, you can go with open source tool like InfluxDB or Prometheus. And I think that one of the points that a monitoring system should have independently, that if you are doing the on-prem or you are doing the as a service one, or you are running one by yourself, is the flexibility. So you never know what we are going to need or what you will look for inside the monitoring system. You know that at some point you will have to ask any question to it. So if you have a lot of ways to push data in or to pull data from your application, or a lot of different ways to query and aggregate your points, this is really what I think is valuable in a monitoring system. So the ability to interact with it in a lot of different ways.
Okay. So is it kind of a performance thing that you're monitoring then, or is it the speed? I'm just kind of throwing a couple things out. Exactly when we talk about monitoring containers, what specifically are we looking for? Are we looking for vulnerabilities? Are we looking for network performance? Are we looking for speed of whatever it is that the application that's being the container application is performing, and so what is it exactly? I guess that's kind of the general question.
Yeah, it's very hard to tell because you are looking for everything you can look at when you will have an issue. So it's not really a question about what I need now, because if you are here having a webinar, we don't need anything. My monitor can even not exist. But when I will have an issue, I need to whatever I can use to get what I need. So it's always a question that you need to answer earlier than when you have an outages. So that's why I'm speaking about flexibility more than everything else, because you need to be ready for whatever it will come. So for containers, I can tell you what we are looking for, or what we look at when we have some issue or when we need to figure out what's going on. Because in a distributed system is very different compared with traditional monitoring, because you don't really have a state of the world right now. I mean, you accept that as a reliability engineer, I know that everything is in a bad shape by default, and when everything is quiet, there is something going on. So maybe nothing is working, or that's what I assume. So the fact that we write like fault tolerant application means that we need to embrace and accept the failure. So we don't know what is failing. We know that something is broken, but you need to figure it out, digging in your monitoring infrastructure. So we look for container restarts, we look for the latency, we work a lot to write SLO and SLI. So the SLI are the indicator that our service is working. So we have, we collect, I think 50 million metrics every minute. So it's a lot, and not all of them are useful. And usually you are not looking for one metric at a time. You are looking for an aggregation of them. Because if you look at the CPU usage of your server, you don't really know why a request is failing. You know that it's taking longer, but you don't really know if it's failing for that or not. So usually it's an aggregation, and you slice and dice on them based on what you are looking for. So it's we are looking for the application from the metrics from your application. So we instrument our application to send us metrics related to what it is doing. And the fact that we write services that are not that big, I don't like to call them micro, because micro doesn't really give me a dimension. So we usually try to scope them for behavior or for targets. So we have services that do one stuff. Maybe one stuff requires an API and some routines that goes in background, but the responsibility is clear that the task application runs task, or the dashboard application run dashboards. So it's very just for the fact that the scope is clear and easy to figure out. It's also easy to figure out what you're looking for. So let's say task. So you have an application that runs on-demand tasks, and it is very easy to figure out what your customer is looking for. It's looking for the fact that his task will start, and will start on time, and it will take a reasonable and consistent amount of time. So those three are metrics that we look at, and on those three metrics we write the objective of our service, and we verify that those objectives are are running smoothly. So if we have 1,000 tasks and we say that 80% of them or 90% of them needs to run on time, so as soon as they are scheduled or in a latency of 10 milliseconds, that's our SLO. So that's our target. We know that every 1,000 tasks, 800 need to run in 10 milliseconds, need to start in 10 milliseconds. So we describe that as a query, and we have an alert for that. And if the alert goes close to 10 or above or after 10, we get a page.
Okay. All right. So I guess I understand that. And I understand that security is part of the continuous monitoring, if you will, of, you know, because there's so many things going on at any time. But are there certain considerations that are specific to containers that, you know, in monitoring from a security standpoint that organizations need to be aware of, Cherie?
Yes, so just in general, like without speaking about security even, monitoring containers is very different from monitoring traditional VMs. Like if we think about it, we discussed in the beginning about containers being ephemeral and they come and go. So for example, if we think about monitoring CPU and memory, right? We want to monitor the performance. So typically we would monitor it in a server level, but then when you run Kubernetes, like you run multiple containers on one server, and probably the CPU and memory in the server level are not really interesting anymore. Same goes for networking data, right? So even if I have a very low consumption of resources in one of my servers, but then when I look at the pod level or the container, it actually reached the CPU limit and it's not functioning, then I have a very big problem. So probably the traditional tools will not be able to detect that. And this is also very similar to how we treat security. So if we think about it in traditional applications, we had to monitor security for specific things. So we still monitor the same things, like for example, not having root access is very similar to the fact that you would not give root access in a VM. Or I don't know, like keeping your tokens and your password secure is still the same thing. However, the tools on, you know, how to actually monitor these things and how to secure the cluster. So I think these actually changed. In terms of really like how to monitor for security, so it's really about keeping the containers secure. And there are a few best practices to that, but I think we mentioned a few of them. So like, you know, the secrets, and then also it's in terms of using only trusted registries, like taking your images only from registries that are either private or ones that you trust because you sign them somehow, like using a digital signature or using any other tool. So there is a difference between, you know, and there is a lot of new challenges that we face when we try to secure and monitor the security part in container versus traditional applications.
So with that in mind, then, you know, are we seeing any instances of security actually being compromised by, you know, during the containerization of applications? You know, especially because of that ephemeral nature, are hackers or bad actors actually taking advantage of the, you know, that ephemerality, if you will, and actually kind of using it to their advantage to introduce bad code or malware?
Yes, of course. So we see a lot of that. Like I think only in the last year or so we've seen about 5 like critical vulnerabilities regarding either like the isolation, right, between Docker containers or between the runtime, and also within, you know, in the open source community. We know that Kubernetes is open source, and there has been a few vulnerabilities detected in Kubernetes. Some of them are inherent to the fact that these are containers, but some of them can also be sort of overcome in different ways. Like for example, one of the security vulnerabilities that we've recently seen is not cannot be exploited if you don't use roots to your clusters, or if you use role-based access. So things like that basically help us to eliminate most of the vulnerabilities, but it's not 100% assured that you will not have any security vulnerabilities. But definitely, yeah, we see things that are related solely to containers. Yeah.
Okay. Okay, great. So what about microservices? And we've been focusing so much on containers, but a lot of organizations are using microservices as well. So I'm wondering if the monitoring of microservices needs to be done in continuously as they are with containers. Is that kind of a different animal altogether? Gianluca, we'll go with you.
I mean, one of the reasons why, I mean, I don't know, this is a chicken in the eggs. I don't know if microservices are cool because containers are cool, or for the opposite. But in any case, like, there is definitely a spike on both. So people are using containers more and more, and they are onboarding the technology. And when you have containers, you start to figure out that it's good to separate your application in something that you can control. And I think it really helps we get back to the cultural, and how do you to the culture of your company and your teams, and how you try to solve problems, because we always need to remember that what we try to do is to solve issues and not to try technologies. But at scale, it's easy to split the work if you have microservices, because you can give a microservices to different people or to different teams, and they can figure out by themselves what needs to be done, and you can leave them the ability to take decision and to write the implementation that they like, and they are easy to change if you need to change them. But this approach grow how dynamic an environment is, and we are piling dynamics. So containers makes everything more dynamic, and microservices are kind of not helping in decreasing the entropy of the system. So this makes the growth in complexity, and the complexity needs to be understood, and the way that we have to understand complexity is with monitoring. So monitoring becomes the way to try to figure out what's going on. And we get back to the situation where we can't really assume anymore that an application or a system or a microservices environment is working. We need to assume that something in some place is not working, and we need to figure out why. So it's not like before that back in the day, I was used to work in a 2 or 3 server environment with the same application replicated in a bunch of servers. So what you will do, you will take the logs, and you will see, and you will look for how fast they go. If they go too fast, there is too much traffic, so something's wrong. If they go too slow, something's broken on the other side. So that was like the monitoring for a lot of people. But this doesn't apply anymore. So you need to build aggregation, you need to be alert. Some alert will page you and slap you in the face and say, oh, you need to fix that. Some other alerts will just be another metric. Like the amount of alert you get is a metric by itself. So it can quickly become very fascinating for me because I like it, but also scary for other people.
Scary, yeah. I would go with scary myself, but that's just me. All right. Well, then, that actually kind of brings up another point, which is the fact that I don't, there's so many things that you have to look at when you're doing the monitoring, and it seems like it's got to be, this holistic process to understand how each part of the process impacts the other, and how the again with the ephemerality, but that's got to have a huge impact on the success or failure, if you will, of containers. So, but there doesn't seem to be any type of tool out there that really kind of addresses the whole end-to-end solution. So how do companies kind of deal with that? I guess they could cobble together a tool chain that using technologies that they think is going to work best for their company. But I wonder if that's really going to have all of the information that they need to be able to make those intelligent decisions.
Yeah,
Giancarlo?
yeah. I think it's a collaboration. Like there isn't. I think there is not a tool for that. There is not a magic tool that right now you can use to figure out what's broken, because it's mainly about collaboration. It's about previous experience. So the experience that your team had during previous outages is like it's valuable, and not a lot of monitoring systems are helping you to figure out what other people in your team did 1 hour before when the outages was starting or when they do the deploy. So there is not a tool, and there is no a secret tool that nobody knows. So there isn't, and you need to do a stack of them in some way. Some companies and some open source tools like Influx Data does itself tries to give you a set of tools that you can chain together and do whatever you are looking for. You know, in the version in the new generation of InfluxDB, we are trying to consolidate all of them in once, so it is not a stack anymore. It's one tool that you install. It does everything you need, but still, I think there is a lot that we can do and we should do in terms of driving visualization and driving alerts based on sharing experience. So everybody has a MySQL running. Everybody has Go application or Node.js application running. Everybody sends logs that has error and warning and debug info level. So we should use them and give to other people the ability to use our operational experience, like just throwing data in. So I think that what there isn't, and I think we really need that, is the ability to share those information as a package and have other people just enjoy them and giving back what they learn using those resources. So yeah, that's why we have traces, and at Influx we use Jaeger, and we open sourced a module to store the trace in InfluxDB. So what I like, even if I don't, I joined InfluxDB because I was a user and I liked what they was doing. So I think I was gonna say the same even if I was working for another company. What I like about Influx is the fact that it is a database company. So what they do is a database, and a database gives me the flexibility that as an operator I was looking for. So I can query my data in a good way, and I can do aggregation, I can do graph, but it is a database, so it's there and it's easy to figure out stuff. The complexity that we need to build and I think in the open source there isn't a solution. Even Grafana does a lot of good stuff, but it's not there. It's like in as I say, building that operational experience. So I would like to see a system where you push your data in and it gives you like the basic. So it gives you the error rate and the latency and the heat map with the latency distribution and this kind of stuff by default. Because if you know what you are gonna, like how your data looks like, you can graph that, and from there you will start from another level that is more focused to your application. So I think that's the biggest criticality here. That I don't think there is at least in the open source a tool that does that efficiently. But at least if you have the flexibility, you can try to figure it out, but like to make it.
All right, great. So here's one for you, Shuri. I'm looking at the questions here, and we've gotten some really great questions in. And please, if you do have a question, go ahead and use your GoToWebinar control panel and submit your question, because I mean we've gotten so many good ones in so far. I'm kind of totally going off script here by asking the questions now, but I want to make sure that we get to them. So, you know, do you see any difference? Because containers traditionally have been open source, but you know, over the last year or so, we've seen Microsoft kind of come into the fray. So, you know, do you see any major differences in how to secure and monitor in Windows versus Linux containers?
So I think, again, the best practices are exactly the same. I mean, if we look for like best practices for securing containers, I think that most of us are already aware of, not running as root, securing the container registries, and only using, trusted secure images. So it doesn't really matter whether if it's a Linux container or a Windows container. The fact is that both of them can be exploited, and both of them can be vulnerable, even if it's not the container itself. Maybe it's a specific library that you're running and is either open source or proprietary, but a hacker actually found a way to exploit it. So the idea is, again, to actually know what you're using in terms of both open and closed source, and then also to use, like, for example, image signing to make sure that your container is always safe. Another thing that we didn't really touch upon is like setting resource quota to make sure that no one is actually using our system resources. So basically, we're sort of enhancing security by preventing from some sort of compromised containers from consuming a large amount of performance resources like CPU and memory. And maybe the hacker is doing that because he has like a Bitcoin mining system, or just because he wants to disrupt the service or perform any type of malicious activity. So these are like the main aspects of container security, Windows versus Linux containers.
All right. So it kind of sounds more like the environment is almost vendor agnostic, whether it's proprietary or open source. It's regardless, it needs to have a high level of security attached to it. So just like everything else these days. So okay,
yes.
we are.
Specifically for open source, we see, first of all, in terms of statistics, like we see around 80% or even more than that of the code that is written out there is open source. So like protecting the open source is sort of like 80% more important than protecting your proprietary code. And also there is an interesting fact that, of course, open source is just out there, and then a hacker can access it, can look at it, and can basically modify it, create a pull request, and basically, if the maintainer accepts their pull request, they may be already exploiting like hundreds, thousands, or even millions of users that are using that open source version. So this is why it's like extremely important, even though, of course, both are very important in terms of security.
Right. Okay. So I guess this begs the question then, and this could be for either one of you. Is it really worth monitoring individual containers, or can we just kind of focus on groups or particular services? Are we kind of overdoing it by looking at individual containers? Yes, no? I got the stumper question today then.
So basically, of course, if you're running like multiple clusters, right, and each one has a very large number of services, so you'll find it kind of even not practical to use like things like monitoring each and every one of the containers and use like static alerts, like when the number of pod X is larger than Y, or things like that. Like simply measuring the number of HTTP errors for every container doesn't really make sense, because of course the values, they change in every region, they change in every application, like data center, cluster. So it's really difficult to manually adjust the alerts. And of course, when it's not done properly, you will have many false positives, and false positive will actually make you wake up at night, or like have very severe issues due to the fact that it's not really an issue. So for effective monitor, it's really important for the system to automatically understand the severity of this incident, whether if it's by grouping certain pods together, or grouping certain containers together, and also proactively alert you whether, right before the issue becomes a downtime of the system, right? So decisions like that must be at least backed up with some automation in the background. So this is what basically we believe. And then, of course, there is, the important fact for that if you automatically adjust the new state, like in terms of the baseline, it will reduce a lot of the maintenance that you have to do.
Okay. All right.
Yeah, I think it's also worth to mention that it really depends on who is looking at the data. So as a developer and in general, the company is happy to know that their customers are happy. So my customers aren't happy if they use 20% of memory or 35% of memory. They usually don't care. They are happy when their query runs smoothly, or they can get data they're looking for, whatever. So depends on what you're looking for. So if you are a developer, you look for the metrics for your application. But if something breaks and you are a security engineer, you need to go deep on the single container or on the single VMs to figure out what's going on, what's broken. So you still need to have all those information, and the way you interact and query them depends on what you're looking for or who you are.
Okay. All right, that makes total sense. We are, let's see, about 9 minutes to the top of the hour. So I'm going to go ahead and get to our last topic, which is the all-encompassing more, because I thought there are a couple things that maybe we should kind of keep on the horizon as far as container management is concerned. And one of the things that kind of is starting to kind of pop up more in conversation is the idea of predictive analytics and AI being a part of the container landscape. So do you guys see monitoring, maybe Shuri, you can start with, we can start with you, but do you guys see monitoring as kind of that gateway, if you will, to predictive analytics and AI, and really what role might they play in the container management landscape?
Yeah, so I think it's really related to the last topic that we discussed, like where it doesn't really make sense to manually go over the different stats and see like the CPU going up. There should be some automated way to let you know that the CPU is going up. But also these metrics cannot be static, right? You cannot just say when the CPU is over 70%, do that, because sometimes it doesn't really make sense. There is no issue. So you need to have something like machine learning / AI, and you need to adopt this kind of approach. And then you can leverage sort of the AI to constantly track the millions of events that you have and that we discussed in real time. And then they will alert you when that's needed. And this will basically enable the teams to focus on other critical tasks, rather than manually tracking all kinds of alerts and seeing all these alerts when they pop up. So it's also important not to be both to remember that AI and machine learning is something that takes time. So it will basically take time for any tool to learn the patterns of your alerts and of your system. But also that there may be, of course, manual intervention there. It really depends on the system and of course the magnitude and how big it is. But I definitely think that AI can help here.
Okay, great. Gianluca, do you have anything you want to add on regarding AI, predictive analytics, machine learning, all of that good stuff?
Not really. I can't say that I'm an expert on that, so no. But I had an experience recently where we was designing a queue system, and it was definitely interesting to see not just how deep the queue was, so how many messages was in the queue, but also to aggregate them with other information from other sources, like how many messages the client was enqueuing. So there was all those data and information, I bet, that aggregated and like used with, and to train a model in AI will be very helpful to predict how the seasonality is, or how to scale accordingly based on not just how many messages there are, but also how many they will come in the next reasonably short amount of time.
So kind of adding a level of proactivity to it. So that's great. Okay, great. So looking ahead then, do you guys see monitoring tools evolving so that they also kind of include metrics that speak directly to like business metrics, you know, as far as like speed or performance, or, you know, something that kind of speaks to that bottom line? Because it seems like a lot of, you know, what the metrics are showing these days are, you know, great for the IT folks, but it's kind of hard to translate that into what value it brings to the business as a whole. So do you guys see that changing at all?
I hope so. Yeah, I think it's changing. At least, I mean, I think that it is, and it should change like quickly. But yeah, as I said before, there is value. Like the value is where when the customer is happy. So to know when the customer is happy, IT people doesn't know when the customer is happy. So I don't. I mean, I can guess, but there are people that are better.
You know when they're not happy, that's for sure.
Yeah, I know when they're not happy, but yeah. So it's definitely something that we need to join force with other departments, and yeah, it comes back to the idea that a single signal doesn't tell you anything usually. So you need an aggregation to build a context and to have a good picture of what's going on. And definitely what used to be a business metric, and only business metric, can be very useful. Like even the number of ticket supports get, it's a useful metrics that we can use and aggregate with other metrics like the latency for some specific request.
Excellent. All right, great. Shuri, any thoughts on that? Or
no, I definitely agree. I just think that we don't do it today enough. I mean, we should definitely aggregate different metrics from the organization to, you know, see like the bigger picture. And today every department is more focused on, you know, the day-to-day work and what they are doing. And maybe in the future, you know, in bigger organizations, we will actually reach the state where we have things like, you know, matching metrics between teams, and also doing that proactively in real time will definitely benefit the business.
All right, great. Well, looks like we're about 3 minutes to the top of the hour, so I think we may have time for maybe one more question. We've been taking a lot from the audience, and I do appreciate everybody who has submitted questions, but not sure who this should go to, so I'm going to send it to Gianluca first, at least. What are your thoughts about Ansible and integration with containers, configuration management, and deployment?
Yeah, internally we don't use that much Ansible and tools like that. I used to deal with them a lot before joining Influx, and I liked that until I saw an alternative. So right now we use a lot more like immutable environments. So we provision VMs, and we provision Docker images, and we roll them and spin them out in a more like a pull-based model than a push. And I like it a lot more, and it's also one less tool to use and maintain, so that makes my daily job better. And so I don't know. I think we should definitely use them, but in the more for I really like the immutable infrastructure for my daily job. So I don't know if it does apply for yours or for the person that did the question, but if you can come to a state where you can replace stuff and not update them, it will be, I think you will enjoy the immutable force side of the force. And yeah, I mean, you can even use Ansible to provision the image that you will push or the VM that you will push, but it will it's not something that I will do live. It's something that I will do I do before in my CI, and when I push that, it's already what is going to run without any change.
All right. Okay, great. Well, we're a minute to the top of the hour, so time flies when we're having fun. I do want to thank everybody who did submit questions. There were some really great ones. If we didn't get your question answered, or if you need clarification on anything, just please know that the folks that are on this webinar, both on the front end and back end, will be getting a copy of all of the questions. So I'm sure they'll be more than happy to follow up with you offline to get your questions answered. But again, thank you for very much for submitting your questions during today's webinar. Also want to remind the audience real quick that today's webinar has been recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email after today's webinar that contains a link to the webinar on demand. And as I said earlier, we also will be sending out a link to access the ebook on whenever you want it. You can just click on it and it'll download right to you. With that, Gianluca and Cherie, thank you so much for taking the time today, joining me. Such a great webinar, lots of good information. Thank you very much.
Thank you.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.